So greetings students, we'll be moving to the second problem of your Gauss Seidel. So the first problem we have seen about the normal voltage equation, that too with two PQ buses, how you have to solve your Gauss Seidel with up to first iteration we have seen. So generally for a computational purpose they will be asking up to single iteration with respect to your Gauss Seidel problem. But in case of your Newton-Raphson problem, that is Newton-Raphson is somewhat advanced methodology than this Gauss Seidel. For that, they will be making use of more than one iteration. So this is the problem. So over here, what they have said is that uh, this is the structure of your system, and over here there exist four buses. Okay, so it is evident from the figure that there exist four buses, and among those four buses the bus data will be given in the table. So you just take down this single line diagram, and I will be moving towards the table. So this is the diagram. So they have given you the value of your admittance directly. Okay. So if they are giving impedance means particularly they will be specifying in the problem. The given value is in impedance, like that they will be specifying in the problem. Otherwise, uh, by default it is your admittance only. So I hope you might have taken down the single line diagram. I'll be moving out to the bus data. So your first bus. So your first bus is generally here they have asked you to take it as a slack bus. So the slack bus won't be having any kind of your real and reactive power. So it has only voltage. It is 1.06 at an angle of 0 degree. So here they didn't give separately del. Instead, they have given along with your voltage. Okay, so it is your slack bus. So this is given in the question itself. And with respect to the second bus, so it is 0.5. And over here, with respect to the Q, so they have given out a range. So the range here is from 0.1 less than or equal to Q2, which is less than or equal to 1. Okay, so the reactive power at your bus 2 varies from the range of 0.1 to 1. Okay, 0.1 to 1. So over here the voltage also they have given 1.04. So can anybody say me what kind of bus is this? The second bus, what kind
PQ
of
bus,
bus?
sir. PQ bus.
Uh, just make it clear, okay? That is
Load
PQ.
bus, sir.
So your load bus is only PQ bus, okay? For your actually for your PQ bus, what are the given quantities? Your real power and your reactive power, right? And over here you have to see the voltage. So the second bus, they have given the value of your voltage, okay, but they have given the value of Q to be in the range, but not as a fixed value. So this reactive power is in a wide range, but whereas your voltage is a fixed constant value as 1.04. So this contributes to a what kind of bus? Can now anybody guess?
PV bus.
Yeah, it is a PV bus. It is a PV bus. Okay, from the given data itself, you can identify the type of bus. But in most of the cases, they will itself will be giving the type of the bus also. Sometimes they might not. In such case, you have to take it out. Okay. So the third bus, they have given the
Slack
real
buses
power
they
to be.
will give real and reactive value, sir.
Yeah, for Slack bus, they won't be giving you real and reactive value. They will be
But in,
always mentioning your voltage.
but in certain cases they won't be mentioning slack bus. In that case, what they will do, sir?
Yeah,
Normally,
yeah. Actually, so in such cases, what you have to do means that is, for example, over here you can see in such criteria also you can see. Now they didn't give you the slack bus, okay? Now they didn't give you the slack bus, and they didn't give you the PV bus. They didn't give you the type of bus itself. Okay, in such case, what you have to see is that, so, and over here sometimes they might be also giving you the power to confuse you. Okay, like they might be taking around some 0.6, and over here they might be getting around some other range or some other values. In such a case, you shouldn't be confused. Okay, those are rare case only. They won't be asking like that. Okay, for your kind of level, they won't be asking. But if they are asking means, what you have to do is you have to see through the voltage value. So in the voltage value, which is having a very high magnitude, whether your first bus or your second bus. So like that you have to compare. So in this case, your first bus is having a very high magnitude of 1.06. It is 0.02 times greater than your second bus. In such a case, you have to consider this to be a slack bus. Okay, so while dealing with the algorithm itself, I have told you about it. That is, you have to consider the uh, generator with the higher voltage rating as your slack bus. Okay, so as per the question, this is your slack bus, and this is your PV bus. And moving on, so they have given you the PQ value, and over here they have given you the PQ value, and this is a dash. So this corresponds to what kind of bus? It is a
PQ bus.
PQ bus. And coming to the fourth bus, it is point 0.2, point 0.1, and over here it is dash, and hence it is a PQ bus. So this tabulation is also given in your question itself, so no need to worry. And so this is your single line diagram. So now we'll be moving towards your solution. And for your easier understanding, I'll be again drawing the single line diagram.
We need to find out which find using which one, sir? PV or PQ method, sir?
Yeah, that I'll be saying, man. Actually, here it is very clear that they have given you the PV bus. So we have to move towards your PV only, not PQ. Okay. So how I'll be explaining, step by step I'll be explaining. Okay. More or less it will be the same. Okay. At the step 3 only there will be slight deviation. So 1, 2, 3, and then 4. So you guys just try to form the Y bus matrix by yourself. you know to form the Y-bus matrix, right? So it is corresponds to a 4 cross 4 matrix. So you just try to form by yourself. So as per the step one, formation of admittance matrix or your Y-bus matrix. So as I said, it is a 4 cross 4 matrix. So it has Y11, Y12, Y13, Y14, Y21, Y22, Y23, Y24, followed by Y31, Y32, Y33, Y34, and last it is Y41, Y42, Y43, followed by Y44. I just try to find it. So for your Y11, so what are the buses are connected? So it is Y12 plus your Y13. So it is around 1 minus 5j plus 1.2 minus 4j. So you'll be getting around so Y22 it is Y21 plus Y24 plus Y23. So it will be 1 minus 5j plus 0.5 minus 4j plus 1.1 minus 2j. So Y33 will be Y31 plus Y32 plus Y33. So it will be 1.2 minus 4j plus 0.5 minus 4j plus 1.2 minus 3j. What is the value of your Y11? Can anybody say the value of your Y11?
2.2 minus 9j.
Right, 2.2 minus 9j. And for your Y22,
2.6 minus 11j.
yeah, 2.6 minus 11j. Y33,
2.9 minus 11j, sir.
2.9 minus 11j. Next, you will be moving towards your Y44. So it is Y24 plus or Y42 plus your Y43. So it will be equal to 1.1 minus 2j plus 1.2 minus 3j. So it will be equal to Y44 value
2.3 minus 5j.
2.3 minus 3. Okay. So you can just write the diagonal elements around like this. So off diagonal elements, it is very simple, or the transfer admittance, it is very simple. You have to just negate the value. You have to make it minus. Okay. So hence your Y bus will be equal to. So what is the value of your Y11? It is around 2.2 minus 9j. And y12. So for your y12, it is 1 minus 5j. Okay, so you have to just negate it. That is, you have to make it negative. So this becomes minus plus 5j. Okay, so y12 over next y13. So for y13 it is 1.2 minus 4j. So you have to again negate it. So it will be minus 1.2 plus 4j. And coming to your y14, it is there's no connection, so it will be 0. Okay, so you can just by symmetry property you can just write the same values over here, minus 1 plus 5j and minus 1.2 plus 4j, and over here it is 0. Okay, and for with respect to your y22, so you'll be getting around 2.6 minus 11j, right? So 2.6 minus 11j, and this is y1 21 and 22, and then y23 is it is minus 0.5 plus 4j. Okay, and then y24 is minus 1.1 plus 2j. Okay, and after that you can just by symmetry property you can take it out this side, so it will be minus 0.5 plus 4j, and over here it will be minus 1.1 plus 2j, and for your y33 it is 2.9 minus 11j. Okay, and your y34 is minus 1.2 plus 3j, so you can make it symmetrical, so it will be minus 1.2 plus 3j. Finally, with respect to your y44 it is 2.3 minus 5j. So this is your y bus matrix. Okay, so you have formed your y bus matrix in a simple method. Okay, so this is for a 4 bus system. And after this we will be moving towards the initialization. Okay, so initialization of the bus voltages. And first you will be starting with your slack bus. So your slack bus at n number of iteration, it will be carrying out the same value. So you can just put like this. For even for n iteration, it will be the same value. So it is 1.06 at an angle of 0 degree. So this is what it is given in the question itself. So you can take this as 1.06 plus 0j per unit value. Okay. So we have taken for your slack bus. So now coming to the second bus. So second bus, as per your question, it is a PV bus. It is a PV bus. Also, they have given you the voltage. So voltage is given. So you have to consider that voltage as the initial value. Okay. So your V2, not you have to consider the voltage value which is been given. So it will be 1.04 plus 0j per unit. So in bracket you can just put it as the generator bus. Okay, so after this the other two buses are correspondingly it is a load bus. So V3 naught, so it is PQ bus. So V3 naught, as per the algorithm what you have seen for the PQ bus, you have to consider it to be 1. Okay, it will be 1.00 plus 0j per unit, and for the fourth PQ bus, so it will be V40, it will be equal to 1.0 plus 0j per unit. So we have initialized the initial value of all the 4 buses. Okay. And after this, as per the algorithm, next you will be moving towards your iteration step. Okay, so before getting into the iteration step, you have to write your voltage equation. So we will be moving on iteration step. So we'll be putting k equal to 0 on a first iteration. Okay, and the slack bus voltage remains the same. It will be 1.06 plus j 0.0 per unit. Okay, this is with respect to your first iteration. And next we'll be getting into the voltage equation Vp. Okay, so Vp k plus 1 will be equal to 1 by ypp into pp minus jqp divided by vp not conjugate. Okay, and over here minus summation q equal to 1 p minus 1. So ypq remains the same, vq k plus 1. Okay, so after this minus summation q equal to p plus 1, it extends up to n, it will be y pq and this will be vq k. Okay, so we have written the voltage equation. So now coming to the value of p equal to 2 and k equal to 0 in this equation, the voltage equation, if you are putting out, so it will be v2 of 1, this will be equal to 1 by y22 into p2 minus jq2 divided by v2 not minus summation, so q is equal to 1 and p is 2, so 2 minus 1, it will be again 1, so y2 q followed by v q, so k value is 0 1 minus summation, so p is 2, so it will be q takes to 3 and n is 4, so total number of buses totally here is 4, so it will be y 2q followed by v q, so k is 0, right? So k is 0. So this is your value of v2 dash. What is the parameter that we don't know? So in this equation, what parameter we are uncertain about?
Generated power and load demand power, sir.
Yeah. Of course, P2 and Q2 you don't know. Actually, here in the previous case we have seen about the generator and load demand power, but the difference between both the problems is that here they have given the real power of the bus, real power that is flowing in the bus they have given. Okay, so over here you can see. So they didn't specify any kind of generator and demand. So they have particularly given you the real power that is flowing in the second bus, third bus, and the fourth bus they have given. But the thing is that still the uncertainty remains with the parameter of the reactive power. Okay, so with the reactive power, the uncertainty still remains because they have given you the value of reactive power in a wide range. Okay, the wide range they have given. Also, this is a PV bus. So, as per the algorithm, we have to step towards the reactive power equation. You have to move towards the reactive power equation. First, you have to find the reactive power Q2. After that, you have to apply in this voltage equation. Okay. So I'll be moving on towards your reactive power equation. So in the generalized format, I'll be writing QP calculated K plus 1. That is for your first iteration, it will be equal to minus imaginary. That is, you have to consider only the imaginary part. Vp K star. Okay, so this equation we have already seen with respect to your algorithm. So if you want to just see through it, summation q equal to 1, and this first to p minus 1, and then after that ypq, and then vq k plus 1 plus summation q equal to p, and over here it is n, ypq, the same thing, vq k. So you have to consider only the imaginary part, okay? To consider only the imaginary part as it is for the reactive power. So now we have to substitute the value. So Q2, as it is a PV bus, for this bus alone, this equation you have to solve and you have to put it in the voltage equation. Q1 it will be equal to minus imaginary into V2. So K value is 0. Okay. So this one you have to put substitute it to be y21 v1. So okay, I will be substitute it. After that I will be writing it, so it will be easy for you. Summation q equal to 1, so p minus 1 is 1, so y 2q, so vq, and over here it is k is 0, so it will be 1, the summation q equal to 2, and over here it is 4. After this it is y p, right? So 2q vq, so k value is 0. So this is the equation. So let us expand it. So minus imaginary p2 naught star into y21 vq1. So this is a single element plus y22 v2 naught. Okay. So after this y23 v3 naught. So after this y24 v4 naught. Okay. So after this you have to substitute the values. You have to substitute the values. So we'll be getting minus imaginary into 1.04 into minus 1 plus 5j. So in calculator directly you can just use this value, and so here it is 1. Okay, so here it is 1, so this is slack bus. So into 1.06, okay, plus, so your y22 value it is 2.6 minus 11j. Okay, so your v2 naught value is 1.04. Okay, so plus 23. So 823 is it is minus 0.5 plus 4j, and after that the initial value it is 1 plus 0j plus y24 it is minus 1.1 plus 2j, again it is 1 plus 0j. Okay, so try to solve this equation up to this 1.04. You just solve it. So use a calculator and get into the complex mode for solving it. So next hour you're having a class. So current next hour whether you're having
Sir?
next hour whether you're having class.
No, sir.
Okay. So I'll continue and I'll just finish this problem. Okay. So just bear with me because it is afternoon. I already know that. So you might have know that coming 19th for your exam might be starting. You know about it, right?
Yes,
Whether
sir. Yes, sir.
yeah. So for the exam, the portion will be up to this problem. Okay, up to this problem it will be, that is with respect to your PV bus.
Sir, only one iteration, sir.
Yeah, up to one iteration alone will be there. When
Okay,
if they are making a second iteration means it will be a tedious process, so they won't be asking the second iteration. In Gauss-Seidel method, they won't be asking, but in Newton Raphson they will be asking. So Newton Raphson is not there for your exam. Okay, so you will be getting the value as minus. I hope some might have solved it. So you'll be getting it to be Q calculated equal to, so minus imaginary of, after solving that equation you'll be getting 0.0458 minus j 0.1456. So now over here how you can have to get this value means, first you have to take the imaginary part alone, that is this part alone you have to consider, and after that you have to negate it with minus. Okay, so this becomes minus of minus j, so we are considering imaginary part, so j can remove 0.1456. Okay, so now we have to multiply the minus inside. It will be Q2 calculator to be equal to 0.1456, okay, per unit. Okay, so now we have got the value of your Q2 dash, sorry, Q21. But next step is that as per our algorithm we have to check the Q limit. So we have to check the Q limit. So as per the Q limit what it is given, so your Q limit it is varying from 0.1 less than or equal to Q2, which is less than or equal to 1. Okay, so now if you're substituting your Q2 calculated in this over here means, so as per the equation whether it is satisfying or not means 0.1 less than or equal to 0.1456 is less than or equal to 1. So the specified range is, so Q2 dash calculator is within the specified Q limit, because So 0.1 less than equal to 0.1456 is within the limit. So you can easily infer from the range itself. Okay. And now for bus 2, you have to take your Q2 as 0.1456. So now you have to consider this value in the voltage equation. In this voltage equation, you have to substitute the Q2 value over here, and we will be arriving at the solution. Okay. So moving on to V2. So I hope you are clear with respect to the Q limit. In some problem, the Q limit won't be satisfying. Okay. So if the Q limit is not satisfying, means what you have to do is, I have already given the algorithm. What is the consequence you have to take if the Q limit is not satisfying? If the limit is greater than the value at the right hand side, then you have to consider this right hand side value as your reactive power. Otherwise, if it is at the more than the left hand side value, then you have to consider this value to be as the reactive power.
சார் இப்போ 1.5 அந்த மாதிரி வந்ததுன்னா 1 சூஸ் பண்ணுவாங்க சார்.
1.5 அந்த மாதிரி வந்துச்சுன்னா you have to go with your 1. அதே மாதிரி இந்த சைடு வந்து பாத்தீங்கன்னா 0.09 0.08 அப்படி வந்துச்சுன்னா you have to select 0.1 as Q value. Okay. So maximum Q limit violate ஆகாது. அப்படி violate ஆச்சாலுமே it is very simple to specify.
சார் அந்த Q limit இன்னொரு தடவை எக்ஸ்பிளைன் பண்ண முடியுமா சார்?
ஓகே. ஸோ Q லிமிட் வந்து மெயினாக எதுக்கு பார்ப்பாங்கன்னா, அந்த ரியாக்டிவ் பவர் ஜென்ரேஷன் அந்த இதில் வந்து அவங்க கொடுத்த லிமிட்டில் இருக்கா அப்படின்னு பார்க்கணும். ஓகே. ஸோ நம்ம வந்து இப்போ Q2 வந்து கேல்குலேட் பண்ணியாச்சு. ஸோ Q2 நம்ம கேல்குலேட் பண்ணது, ஸோ அவங்க வந்து கொஸ்டினில் வந்து ஒரு லிமிட் கொடுத்துருக்காங்க. ஸோ அந்த ரேஞ்ச் கொடுத்துருக்காங்க. ஸோ இதான் அவங்க கொடுத்த ரேஞ்ச். சரியா? இந்த ரேஞ்ச் வந்து அவங்களுக்கு கொடுத்துருவாங்க. ஸோ they will itself will be giving you the range. So it will be இங்கே வந்து பார்த்தீங்கன்னா they have given it to be 0.1 less than equal to Q2 less than equal to 1. ஓகேயா? ஸோ அப்போ நம்ம கண்டுபிடிக்கிற Q2 வேல்யூ வந்து இந்த லிமிட்டுக்குள்ளே இருக்கான்னு பார்க்கணும். அப்படி லிமிட்குள்ளே இருந்துச்சுன்னா வந்து அது வந்து Q லிமிட்டை வந்து வயலேட் பண்ணலன்ட்டு அர்த்தம். ஓகே. ஸோ அதான் இங்கே அது வந்து Q லிமிட்டை வந்து வயலேட் பண்ணல. அப்படி வயலேட் பண்ணாத பட்சத்தில், so what you can take is that you can take the calculated value as your reactive power Q2. So here the limit is not violated. So what we have done is the Q2 value, what we have found out is taken to be the Q2 value. Okay. So இப்போ அதே நேரத்தில் வந்து ஒரு சில ப்ராப்ளத்தில் வந்து இந்த Q லிமிட் வந்து வயலேட் ஆகும். For example, as he asked, sometimes this gets up to 1.5. Okay. ஸோ இப்போ இங்கே 1.5 இருக்கும்போது பார்த்தீங்கன்னா இந்த 1.5 வேல்யூ வந்து எந்த சைடு இருக்கு பக்கத்தில் இருக்குன்னு நீங்கள் பார்க்கணும். வெதர் இட் இஸ் நியர் டு த லெஃப்ட் ஹேண்ட் சைட் ஆர் வெதர் இட் இஸ் நியர் டு த ரைட் ஹேண்ட் சைட் பார்க்கணும். ஸோ இங்கே 1.5 பார்த்தீங்கன்னா இட் இஸ் நியர் டு யுவர் ரைட் ஹேண்ட் சைட். அப்போ வந்து நீங்கள் இந்த 1.5 Okay. So here you have to consider your Q2 value to be 1. Okay. So here you have to consider your Q2 value to be 1 when it is near to your 1.5. Okay. So when it is near to your 1.5, you have to consider like this. Whether if it is less than your 0.1 means you have to take your 0.1. Okay. ஸோ அந்த Q வேல்யூ வந்து நீங்கள் செட் பண்ணுறது தான் இருக்குது. ஸோ அந்த Q வேல்யூ நீங்கள் இப்போ செட் பண்ணிட்டீங்கன்னா அடுத்து நீங்கள் திரும்ப வந்து வோல்டேஜ் ஈக்குவேஷனுக்கு தான் போவீங்க. வோல்டேஜ் ஈக்குவேஷனில் போய் எப்பயும் நம்ம ஐட்ரேஷன் ஃபர்ஸ்ட் ஐட்ரேஷனுக்கு எப்படி நம்ம பண்ணுவோமோ அதே மாதிரி அதே ஸ்டெப்ஸ் தான். ஸோ இந்த Q டிட்டர்மைன் பண்ணுறது மட்டும் இந்த மாதிரி வரும். யூஸ்வலாக வந்து உங்களுக்கு ப்ராப்ளம்லையும் பார்த்தீங்கன்னா உங்களுக்கு ஒரு பிவி பஸ் தான் தருவாங்க. 2 பிவி பஸ் கேட்டாங்கன்னா ரொம்ப காம்ப்ளிகேட் ஆயிரும். உங்களுக்கு ஒரு ப்ராப்ளம் முடிக்கிறதுக்கே என்டையர் எக்ஸாம் பீரியடே ஆயிரும். ஓகே, ஸோ அந்த மாதிரிலாம் கேட்க மாட்டாங்க. ஒரு பிவி பஸ் வச்சு மட்டும்தான் they will be asking. So moving on to the voltage equation. So V2 1 will be equal to, so I'll be directly putting out the values. So this is Y22 value 1 by 2.6 minus J1111 into, so P2 it is 0.5 minus Q2 J 0.1456 divided by your initial value, so minus 1 plus 5J into slack bus value 1.06 plus 0J. Okay, so minus 0.5 plus 4J into 1 plus initial value minus 1.1 plus 2J into the initial value 1 plus J0. So you just try to solve, you will be getting around so okay, I'll be just writing equation, you'll be getting around 3.1408. So you just solve it by yourself. Minus J 11.44. Okay, so divided by this value 2.6 minus 11J. So you'll be writing the polar form as 1.0496. So you just solve by yourself and check it out at an angle of 2.05 degree. So this is the value of your V2 dash, sorry, V21. So as it is a PV bus, you have to do some elaborate steps. The steps is more brief. Okay, but whether in case of a PQ bus, it will be very much easy for you. So next I'll be moving towards your PQ bus, that is your third bus.
சார் ஆல்ஃபா கொடுக்கலன்னா அப்படியே வச்சுக்கலாமா சார்?
ஆல்ஃபா ஆக்சிலரேஷன் வேறு இருக்கும். ஸோ ஆல்ஃபா கொடுத்துருப்பாங்களே ஆக்சிலரேஷன் ஒன் ஆல்ஃபா வேல்யூ தே ஹேவ் கிவன் ரைட்
கொடுத்து ஆல்ஃபா 1
எடுத்துருக்காங்க. ஸோ ஆமாம், இதுக்கப்புறம் நீங்கள் வந்து ஆக்சிலரேஷன் வேல்யூ எடுத்துக்கணும். ஸோ அப்போ வந்து V2 acceleration it will be equal to V2 naught, okay, plus alpha. Okay, so இதில் வந்து பார்த்தீங்கன்னா what you will be getting is you will be getting the same value because alpha வந்து ஒன்றா இருக்கும். So here you will be putting V2 1.
இல்லை சார், V2 நாட் வந்து 1.04 இல்லை சார்.
V2 naught வந்து 1.04 ஆமாம், பட் over here it will be again it will be minus V2 naught தானே. அப்போ இது பாருங்க, இது வந்து உங்களுக்கு 1 ஆயிரும். ஓகே, ஸோ இப்போ இது பார்த்தீங்கன்னா V2 naught ப்ளஸ் ஸோ இந்த உங்களுக்கு ஆல்ஃபா வேல்யூ 1. ஓகே, ஸோ அப்போ V2 1 மைனஸ் V2 naught, அப்போ இதுவும் கேன்சல் ஆயிரும். அப்போ வந்து உங்களுக்கு again it will be having the same value as V2 1. அப்போ வந்து ஆல்ஃபா வந்து உங்களுக்கு வந்து 1 இருக்கும்போது ஸோ போத் யுவர் ஆக்சலரேஷன் அண்ட் த பஸ் வோல்டேஜ் வில் பி த சேம். ஓகே. So if the acceleration is different, you have to solve again. Okay. So here you can just put the value what we have found out. So it is around 1.0496 at an angle 2.045. Okay. So this is what with respect to the second bus. So I'll be moving towards your fourth bus. Fourth bus, I'll be directly writing the equation and I'll be directly writing the answer. You just solve it by yourself. Okay, you just check it out. So V31 will be equal to 1 by Y33 into P3 minus JQ3 by V30 SAR. Okay, so minus Q equal to 1 and over here it tends to 2. So Y3Q VQ1, okay, minus Q equal to 4 and this extends up to 4. So Y3Q, so it will be VQ0. Okay, and now we have to substitute the values. So it will be 1 by Y33 into P3 minus JQ3 by V3 naught star minus Y31 V1 dash minus Y32 V2 1 minus Y34 V4 naught. Okay. So next you have to substitute the values. So upon substituting the values, it will be 1 by 2.9 minus 11J into minus 0.4 plus I'm having some problem over here, I think. Suddenly everything went out. Okay, we just solve for Y3. That is voltage of bus 3, bus 4 by yourself. Okay, you'll be seeing in tomorrow's class. Okay, so again got some issues with the Jamboard also. Okay. So okay, with this we can wind up the class, and tomorrow is the last date for submitting your assignments. Okay, assignment number 1. So don't forget. So try to submit your assignment on time. So that's a very important factor. Okay, based upon that only your marks is solely dependent upon the punctuality at which you are submitting your assignment. I'll be seeing through the issue over here. You just find for your bus 3 and bus 4 because those two are PQ bus only. So it will be easy for you to find. Okay. Okay. With this you can leave. Thank you. Thank you for listening for the class even after the time duration. Okay. Thank you.
Thank you, sir.